Hi, I'm Craig Colgrove.
I'm Murphy.
Murph, you recently spent some time hacking facial recognition data and you wrote a blog post about it. Any big revelations you want to talk about at the start before we get into the details?
Yeah, the thing that immediately jumped out was how easy it was. We ended up using an approach that was a lot simpler than what we had to do for a different blog post that we made on inverting text
Yeah.
embeddings. And that was pretty surprising. There were also a lot of really good papers on it that we couldn't find code for. They were going to be harder to implement, but those papers' results looked even better than ours did. So it's pretty
Yeah,
impressive how
intuition would
much
say
you can
that
get out of it.
faces are pretty hard to reconstruct, but sentences ended up being much harder than faces in the end.
Yeah.
So yeah, we should talk about what it really means to attack facial recognition. Like, what are you attacking exactly?
You're attacking the data itself, like the embeddings that are produced from a facial recognition model.
Okay.
Uh,
What is an embedding?
an embedding is a vector of numbers, and it is those numbers end up getting meaning from an AI model. The AI model kind of takes a look at a picture, in this case, of a face, and it extracts the meaning that it can and the kind of the features and traits of that face, and it spits out a huge list of numbers to kind of memorize to store that information.
Yeah, so this big list of numbers might look meaningless to us, but it holds like all the meaning that that face held, essentially.
Yeah, all the meaning that the AI model recognized in that face. Yeah.
So why are embeddings used instead of just the faces themselves?
the f- Calculating all of that information, having the AI model infer all of that information from the face takes time, and so when you're doing things with the information, it's much easier to do it with the embeddings. You generate and store those embeddings, and then it becomes much easier to make use of that face
Okay. It's
quickly.
probably also a big space saving.
Yeah,
Yeah,
that too.
much smaller to store the embedding than the actual image.
Yep.
Okay, so what does it mean to attack an embedding?
Uh, there's a lot of different things that it could mean. There's attacks that involve trying to figure out if the embedding you have is a member of a group or classification that other embeddings are related to. But the one that we ended up doing here was trying to invert the uh, the embedding back into a face.
Okay.
So getting a picture back out of that embedding.
Yeah, and so you're not going to get the exact picture back, right?
No, you won't get the exact photo that was used to create the embedding or the exact face even, but you will get something that shares a lot of identifying features with that
Yeah.
original face.
Okay. So you want to go into a little detail about the inversion attack that you used?
Yeah, so this inversion attack actually ended up being, like I said earlier, a simpler one compared to the attacks that we
Hmm.
did for text embeddings. For text embeddings, we had to train an AI on the embeddings themselves to try to produce the inverted text. In this case, we didn't need to train an AI. We basically used an existing AI that can generate faces, just random faces. We generated a bunch of random faces and then checked to see if the embedding created by that face was close to, like similar to
Yeah.
the embedding that we had from the original face. And we just did that over and over and over again until we got pretty close.
Okay. And how were the results?
Uh, they're really quite good. We don't have a metric that we measured it
Yeah.
by, how good it is, a strong one at least. But when you look at it, it looks a lot more like the original face than it doesn't look like it. You
Right.
get kind of identifying features about that person that you wouldn't have had just looking at the numbers themselves yourself.
Yeah, I wouldn't get much from those numbers at all. Did it take a long time to run? Like, are you crunching data
No,
for days and days?
no, it did not take very long to run. It took, even when we were running um, a lot of iterations to try to get as close as we could to a good face, it still only took like less than an hour to run
So
through.
what's happening in each iteration?
At each iteration, it's generating a random face, checking how close, like creating an embedding from that face with the same model that was used to create the embedding originally, checking how close that random face was to the original, and then generating another mutation of that random face. So it keeps making slight changes to each random face that it started with, and trying to get closer and closer to the original.
Cool. So in the end, how hard was this? Like, are you an expert in this? Have you spent a lot of time, or is this something that really anyone could do?
I am not an expert, and this is pretty easy. And we actually put this up on a collab notebook that anyone can go mess around with and make changes and play with themselves. Yeah, this doesn't require being an expert and is like kind of shockingly easy.
Cool. And also pretty scary.
Yeah,
What's
definitely
the implication of all this? Like, what could someone use this sort of attack to do?
I think the scariest implication of this for me is that if somebody got access to embeddings like that are in a vector database or something else that someone was using for a facial recognition system, if they got access to those embeddings, they could run an attack like this on all the embeddings that they got and effectively get, a bunch of identifying features of all the people that were in that facial recognition database. Yeah, I think that that's pretty scary, especially given that it's probably lightly protected data because currently most people think that the embeddings aren't sensitive.
Yeah.
And so it might be pretty easy to get a hold of those embeddings comparatively. And they might even be throwing away the original photos of the faces to try to preserve privacy, but then keeping around the embeddings themselves, which...
Sure.
Yeah.
So what can be done to protect against this kind of attack?
You could encrypt these faces entirely with like random encryption, like the embeddings. The downside of that is that they become pretty much useless until you decrypted them. So
Right.
if you were trying to like match a new photo of a face to something in your database, you wouldn't be able to do that. We make a product called Cloaked AI, and that can be used to encrypt embeddings while preserving the distance relationship between them. And so then you could encrypt these embeddings, but still do all of the distance and similarity matching type of stuff that you want to do with vector databases on them. Yeah.
Awesome. Well, thanks for talking to me. Sounds like Cloaked AI can protect these vectors while still preserving lots of the information and usability of them. So that's really cool.
Yeah. Thanks for talking about it. It was fun.